Our goal in this problem is to find the exponential function that contains these 2 points, 2, 20 and 3, 4. The first thing to notice is that these are consecutive x's, so 2 and then 3. Consecutive means one right after another with the counting numbers. Because of that, we can find what's called the common ratio by looking at the y's. Before we jump into that, let's write out our general form of an exponential. So we're looking for a, we're looking for b, and then we can plug it into this function. In order to find b, that's our common ratio. So this is where we're going to compare the y's, the y coordinate of these 2 points, 4 and 20. One thing to notice is that as we go from 2 to 3, we're getting smaller instead of larger. So that means our common ratio is going to be smaller than 1. So we're going to compare this number to this number. So b is going to be 4 over 20, which we can simplify down to 1/5. So b is 1/5. We still don't know a, but we can find a by using one of these 2 points, 2, 20 or 3, 4, and plugging those in to the function. So let's start by writing, let's plug b in, 1/5 to the x. Now, really doesn't matter which one we use, so I'm going to use 2, 20. So I'm going to plug in a 20 for y, in other words, f of x, and I'm going to plug in a 2 for x. Now, this is an equation that I can solve for a. Let's start by squaring 1/5. 1/5 times 1/5 is 1/25. To get a by itself, I need to multiply both sides times 25. You can kind of think about it as 25 over 1 to undo this fraction, which is the same thing as 25. So that undoes the fraction. We're left with 1a, or just a. And then we need to do 25 times 20, which is 500. So it looks like a is 500 and b is 1/5. Let's go ahead and put those into our general form. F of x equals a is 500 times b is 1/5 to the x power. So here is our function that represents this scenario, this exponential decay scenario, and it contains those 2 points. If you wanted to check your work, you could try plugging in those 2 points, and it should yield a true statement.